Good morning. This is the Unit 1 pre-test review. I'm going to do each of these problems as quickly as I can. Let's go to work. Okay. Make sure that as you're doing these, always follow directions. Determine if each of the following is a function or not. If each input has exactly one output, and explain how you know. Now, a reminder on this explanation of how you know, I'm going to explain it verbally. Just due to time, I may not explain it or write it down just due to time issues. Okay, so when you have the test, make sure you validate or explain how you know. Okay, number one, does each input have one output? Well, I notice that there is no repeating inputs. If there's no repeating inputs, yes, it has to be a function. Number two, is it a function? When it's in equation form, I'm looking for exponents of the y variable. If the y variable has an exponent, which it does here, no, it is not a function. Number three, input and output. I'm trying to determine if each input has one output. The input is the type of bird, like a robin, a finch, an eagle, a crow, whatever. That bird's exact weight. So, does every robin weigh the exact same amount? No, it does not. Therefore, this is no, not a function. Number four is the easiest one here. It passes the vertical line test. Therefore, yes, it is a function. When it comes to a sequence, number five, there's literally no or, the word or the word and in it. For example, if you had one or two, three or four, that would be examples of not functions. But since that's not the case here, this is yes, it's a function. Number six, give an example of a function in words explaining the input, output, domain, and range, how you know it is a function. Okay, so I need a function here in words. All right, my input is a person's identity, meaning each individual person, identity. Not like, yeah. So input is each individual person, okay? And the output is their birthday or birth date. What I'm saying here is each person has only one birthday, and yes, that's a function. All right, next one is going to be domain and range. Give the domain and range of the function. Remember, the domain is the x, the range is the y. So first, I'm given the domain. I'm looking left and right. Well, remember that this one goes on forever in both directions. So even though it's going up, it's also getting wider and wider and wider and wider and wider. How wide is it going to get? All the way to negative infinity to positive infinity. So the domain of this one is from negative infinity to positive infinity. What about the range? Remember, with range, I'm looking up and down, up and down, up and down. Well, it doesn't go any lower than negative 7. So my range is from negative 7, and it goes up forever. So it's from negative 7 to infinity. Number 8, what is the domain? The domain is a teenager's identity. Now, I'm being honest with you. When it comes to these word problems, I think the best domain and range is actually what it's asking for. In the weekly allowance, now, if we wanted to put these in numbers, a teenager's identity, that's kind of hard. But if they were just saying, hey, a teenager, we could say, well, that goes from 13 to 19. And the weekly allowance, the less you get would be 0. The most you get, well, I'm sure real rich kids get more money than I know. what to talk about. So from 0 to infinity. But I think what they're asking for a lot of times, if you're talking about something that's not numerical, like teenager's identity, is the best way to give your domain range in those particular problems. All right, moving on. I have to evaluate. So basically I need to plug it in, f of x. So I'm plugging this one into that. So I got -2 times 3 squared plus 6. Well, 3 squared is 9. -2 times 9 is a -18. Plus 6 is a -12. So f of 3 is 12. That means the ordered pair is 3, -12. All right, h of 2, I got to plug that one in there. So I got -2 cubed minus 2. Well, -2 cubed is a -8. -8 minus 2 is a -10. So I got -2, 10. 11 and 12, I got to graph the functions. Make sure I choose the appropriate inputs. Nothing special about this one. Remember, there's two things I'm looking for. One is a fraction, and the other is square roots to have something special. So this one doesn't have anything special, so I'm going to have -2, -1, 0, 1, and 2. Over here, I'm going to have multiples of the denominator. So I'm going to go -8, -4, 0, 4, and 8. I'll come back to do that in a second. Plug these in, and I'm just going to do this one kind of, well, f of -2 is -2 squared plus 2. Well, -2 squared is 4. It's a positive 4, people. Remember that. 4 plus 2 is 6. You see how I did that? So we're going f of -1 is -1 squared plus 2. Well, -1 squared is 1. It's a positive 1. 1 plus 2 is 3. I can see my initial value is 2. And then I should be doing the same thing on these other two, but I can see the same thing is going to happen. It's going to be 3 and 6, -2, 6, -1, 3, 0, 2. Boom, there is my parabola. Not a very good looking one, but it is what it is. My initial value on this other side is going to be 1. Now I got to plug in f of -8. So I got 1/4 times -8 plus 1. Well, that's really over 1, which is a -8 over 4 plus 1, which is a -2 plus 1, which is a -1. Now f of -4, which is 1/4, sorry. 1/4 times -4 plus 1. Well, that's really over 1, so it's a -4 over 4 plus 1, which is 0. Can you see the pattern? It's going up by 1 every time. Oops, 2 and 3. In the next unit, we'll talk about y equals mx plus b and graphing that way. You'll see y-intercept will be 1 and go up 1 and over 4 and up 1 and over 4 or down 1 and over 4, but it's the same thing. Another way of skin the same cat. All right. Number 13, answer whether the following is a given function showing the value of investment tens of thousands of dollars based on number of years. What does the point on the graph show? Well, that's the years. And this is the value of the investment in 10,000s. So after 4 years, the investment is worth $30,000. That's my kind of investment right there. based on the graph, what is causing the value of the investment to increase and decrease. Well, here's one thing about graphs that we can never find, and that is the cause. So the graph does not tell us the cause. Never. It never tells us the cause. It can tell us what's going on. It can tell us the relationship between the two numbers, but it never tells us what causes it. That's our job to figure that out. Okay. Calculate the average rate of change from -2 to 2. -2, 2. 1, 2, 3, 4. 1, 2, 3, 4. So down 4, which is a -1. And the initial value. I need the rate of change and the initial value. So there's my rate of change is -1. My rate of change is 1. My initial value is my y-intercept, which is 2. So here I got to find f of -2 is -2 squared minus 3, which is 4 minus 3, which is 1. It's -2, 1. I got to find f of 2, which is 2 squared minus 3, which is 4 minus 3, which is 1. So that's 2, 1. -1 minus 1 over -2 minus 2 is a -2 over -4. Negative divided by negative is a positive 1/2. So that's my rate of change. And my initial value is f of 0, which is 0 squared minus 3, which is -3, which we could have just looked right there and saw that. So my initial value is -3. Number 17, a banker has been gaining $2,000 per year. That's my rate of change. Currently has a value of $18,000. That is my initial value. Okay, number 18, here's my initial value. And I still need it from -2 to 2, so I got 4 minus -2 over -2 minus 2, which is 6 over -4, or -3/2 is my rate of change from -2 to 2. Now, just as a reminder, we should have been using y2 minus y1 over x2 minus x1 to find that. For the following functions, tell whether they're linear or nonlinear. Give their domain when they are increasing and decreasing. And then give the max or middle. Okay. Number 19, this is linear. Its domain, it's always increasing because it's a line. So it goes from -infinity to +infinity where it's increasing. It never decreases. And it has no max, no min. This one, number 20, it is nonlinear. It is increasing from -infinity. It's increasing till right there, which is to 3. It is decreasing from 3 forever, so to infinity. It has a maximum right here, and that max is 3, 5, meaning the value at the max is 5. All right, rocking and rolling. Last little section here. Use the following graph to function miles per gallon. The car gets in terms of its speed. So speed is the independent variable. Miles per gallon is the dependent variable. Okay. What appears to be the best mileage a car can get, and at what speed does it occur? Here's my best miles per gallon at about 55. So the best is 35 miles per gallon at 55 miles per hour. What are all the possible speeds that a car can drive at? Well, I can go from 0 to 110. Doesn't make sense because you can't go negative miles per hour. So all the possible speeds it can drive at is 0 to 110 miles per hour. What are all the possible mileages your car can get? Well, obviously I can't go any lower than 0, and then the highest is 35. Number 24, determine which graph matches the story and explain why. I started to walk to class. All right, so first of all, I got time and distance. Time and distance. That's what I'm comparing here. Time and distance. Okay, I started to walk to class, but I realized I'd forgotten my notebook. So I went back to my locker. Then I walked quickly at a constant rate of change. So I was moving away from my locker. I got to go back to my locker. I made it all the way back to my locker, and then boom, so C. That one makes most sense. Sketch a graph modeling the function for the following situation. The dog is sleeping when he hears his cat meow in the next room. He quickly runs to the next room where he slowly walks around looking for the cat. When he doesn't find the cat, he sits down and goes back to sleep. Sketch a graph of the function that shows the dog's speed in terms of time. Okay, so this is time, and this is speed. Not how far he went, but rather his speed. Okay. Dog's sleeping. He's not moving. It's not moving. And then he hears the cat meow. He quickly runs to the next room. He slowly walks. Oops. Speed. So, and then he comes down and he walks, looking around at the cat. When he doesn't find the cat, he goes down and goes back to sleep. I'd say it looks something like that. Because again, we're talking about speed. It would look totally different if we were talking about distance. We're talking about how fast he goes. He ran once, so his time, his speed was really up, and then he slowed down to a walk, and then he laid back down. So that's what I got. There you are. Hope that was helpful for you. Good luck on your test coming up. Have a great day.